there's my numbers. All right, so just some, so we're dealing with fractions essentially, right? We're dealing with fractions. They, the same rules apply to number fractions as they do to ones with variables in them. So multiplying fractions, multiply straight across. So if I have 1/2 times by 2/5, it's straight across the top, and that's going to be 2, straight across the bottom, which is 10, and then simplify, so that's going to be 1/5, right? So multiplying fractions is the easiest one. That's the easy peasy one. Dividing isn't any, it's got one extra step. So when we divide fractions, just remember that we take the reciprocal of the second one, and reciprocal just means like the flip of it, right? Okay. And then we multiply the two fractions. Super easy. Okay, but now we're adding some factoring and we're adding some different layers to this, so it gets a little bit complicated. So here's my friendly reminders, friendly hints, things that will help you get through this. Do not multiply the factors through. Like, don't factor it and then remultiply them. Keep them as factors for now. Don't actually do that multiplying through, because it will help you with your NPVs and it will help you later when we're trying to simplify. Remember the steps. We're going to factor everything, then do our NPVs. We're going to simplify each term. So you guys know what terms mean? Terms, those are add or subtracted. Like, so within that, we're going to do a term and multiply or divide. Okay? So, and then we're going to simplify the expression if necessary. Okay. So we're going to do some multiplying first. Step 1 for part A. What's the first thing we're going to do? What's step 1? Factor everything, right? So we're going to go ahead and we're going to factor the numerators, the denominator, the numerator, and the denominator. So if you're uncomfortable with factoring, you can see how this unit's going to be a little bit trickier, because that's like step 1 of every problem we're going to do is to factor. So these ones are nice and simple. They're simple trinomials because they don't have a coefficient. So what are the factors of -12 that add up to a -1? 4 and 3. Which one's negative? -4. So a minus 4, a plus 3. And that denominator, a squared minus 9. What kind of denominator is it? What kind of difference of squares? So we're going to have a plus 3, a minus 3. Anybody excited? Anybody see what we can do right now? Okay, so, but don't get too excited and do it. Don't cross those out yet, because we haven't done our NPVs yet. We're multiplying those by, what are the factors of positive 3 that add up to a -4? -1, -3. So a minus 1, a minus 3. The denominator, kind of exciting because it looks like a difference of squares, but it's not, because that one's not a perfect square. So what can I do with this one? There's something I can do. I can common factor out an a. That's the only thing I can do with this one. It's not a difference of squares. It looks kind of like it, but that single a kind of messes us up. So I'm going to take out an a, and I'm going to be left with a minus 4. All right. So before we start simplifying or canceling anything out, what we're going to do is we are going to do our non-permissible values. Okay, so we're looking at denominators only. So we're going to have a plus 3 cannot equal 0, a minus 3 cannot equal 0, a cannot equal 0, and a minus 4 cannot equal 0. Now I'm not done yet because I actually have to solve them. So this NPV is going to be a cannot equal -3, a cannot equal +3. Oh wait, this one's already done. That's good. That one's already solved. And this one, a cannot equal +4. Maybe I'll write that one again just because I want all my non-permissible values in pink. you can, ladies and gentlemen, if you're okay with solving, like if you're confident with solving, you do not have to write this. When I'm doing my non-permissible values, like if I were to look at this, this is how I would do my NPVs. And I'm not trying to show off, I'm just trying to show you that sometimes when we get good at this stuff, it goes a little bit faster. So I go through. If that's an add 3, if I solve it, it's a minus 3. If it's a subtract 3, when I solve it, it will be a positive 3. If it is a single variable, like there's nothing with it, that's going to be 0. And that's a subtract 4. So it's always the opposite sign. So as I do my NPVs, I'm going to just write them as a list like that. I'm probably not going to do them like this, just because I'm okay with it. I've done it for years and years, and this is what they pay me money to do every day, is non-permissible values. So if this is where you are, please continue to do that, because this and this are the exact same thing. Okay, so we've done step 1, we've done step 2. Step 3, simplify, or we're going to combine, so multiplying. But what did I say? I said don't multiply them through. So this would just be a minus 4 times a plus 3 times a minus 1, a minus 3 over a plus 3, a minus 3, a, and a minus 4. Now, doesn't this line look exactly like that line? Pretty similar, right? All the things that are on top stayed on top. All the things that were on bottom stayed on bottom. Like nothing moved, nothing changed. So oftentimes I don't write this line, like I don't write this second one here. I'll just leave it as this. But again, it kind of makes more sense to write the second line. So as you're learning, putting all the steps in may help it go easier for you. Okay, step, I don't know what we're on, 1400. Let's cross some stuff out. So remember, it has to be the exact same top and bottom. So the first one I'm going to hit is this one. That one's gone. I'm going to do my a minus 3 is gone. And then a minus 4, because I have one on the top, one on the bottom. Make sense? So what's left? Okay. Now, if any of you cancel these out and say my answer is -1, a little piece of a math teacher's heart dies when you do that. Because the A has to be divided into here and here. And it doesn't go in evenly. So the answer is not -1. This is as simplified as you can get it. What's the only other piece I'm missing? My MPV. So comma, A cannot equal plus minus 3, 0, and 4. That is my answer. Remember that we have no equal sign, so we're not solving for anything. Easy peasy. All right, you ready for the next one? Next one's easier but harder. Easier, because is there anything I can factor here? Everything is already factored, right? Everything is already factored. There's nothing, like I can't simplify that anymore, and these are just multiplied together, so that's all I can do. All right, so here we go, non-permissible values. We're looking at the denominator only. So my NPVs, I got 2 different letters. NPVs, what can R not equal? 0. And then over here, what can D not equal? Positive 2. All right, now this doesn't have a bracket around it, but I'm going to put a bracket around it because this whole thing multiplies by this whole thing. And I only want to write it once because, you know, well, I'm a mathematician. I'm efficient. I'm not lazy. Okay, so I'm multiplying straight across the top. So I have D 2 pi RH over 2 pi R times D minus 2. What can I simplify out of there? The 2's, the pi's, the R's. How come I can't cancel out my D's? One's a single D and one has a D minus 2, right? So I can't cancel out my D's here. So we're going to have DH over D minus 2, where R cannot equal 0 and D cannot equal 2. And you're looking at this and you're like, Scallion, there's no R. There's no R in this simplified one. And that's okay, because there was an R in the original before we simplified. And MPVs have to be done before you simplify. That's pretty easy, eh? Like nothing too crazy. I find students have a harder time with the easy ones than they do with the more complex ones. You'll figure out what works for you and what doesn't. Okay, example number dose. What's step 1? Factor everything. Okay, I'm going to hit pause, and you guys are going to try to factor. And I'm going to try to factor. And hopefully we get to the same factors. Can I show you my factoring? No? Darcy's shaking her head no. I just want to show you what I did. How about now? Pushing my luck, I know. Okay, Darcy, don't look. How's your factoring look against my factoring? Kind of good? Sort of good? Okay, awesome. So, now we're going to do our MPVs. Are you guys cool if I do them my way? So C cannot equal, let's go through them. What's this one? Positive 7. This one? Negative 7. This one? 0. And this one? Negative 7. So I've got two of the same, right? You only have to write it once. Okay? All right, so now, before we start canceling stuff out or simplifying stuff, what do we have to do with division? We got to do the reciprocal of the second one, okay? So keep the first one. Change that to a multiply, and now we're going to flip it. Okay. We now have if we have a new denominator, what do we need to do? We got to go back to our MPVs again, right? Because this denominator can't equal 0 either. So this one I've already done. Like this one's already done. It's just this one's new. This is a new denominator. So what is the non-permissible value on this one? Negative 7. We got that. What about this one? Negative 1. So we're just going to add that to our list. So it's not a big deal. But in division, because you get a new denominator, you have to go back and add to your list. So again, you don't have to do this next step. but multiplying straight across the top and straight across the bottom just means that everything is going to be on the top. And everything will be on the bottom. Okay, C's are not good variables to use because like my bracket looks like a C, it's just not great. Okay, now we can go ahead and start canceling stuff out. So I'm going to do the most obvious one, the one that is stacked on top of each other. C plus 1, C plus 1's gone, and C plus 7. Now I have 2 on the bottom. If you only have 1 on the top, it's only going to cancel out 1 on the bottom, right? Like you can't do a 2 for there. It's got to be 1 for 1, okay? So we're left with C over C plus 7. And again, if you guys cancel this out and say my answer is 1/7, a little piece of me will die. Okay, don't do that. And then we list our non-permissible values. C cannot equal plus minus 7, 0, and negative 1. Yep. This doesn't have an equal sign. This is just a restriction. These are your non-permissible values. Oh, if you put equal signs, I'm deducting you a half mark. It is an expression. So no one has equal signs on their page, right? Right? No one has equal signs on their page. Nod and smile. And if you do, nod and smile and then frantically erase those equal signs. Because it's a totally different ball game once we have equations. We do something totally different. Okay, last one, just a combo, pretty easy. Step 1, what's step 1? Factor everything. We're going to get good at this. This common factor on top. Complex factoring on bottom. Do you want me to show you the steps of the complex factoring? You want to do it again? I'll do it, and then you guys can decide if you want it or not. 3x squared minus 5x minus 12. So complex factoring, we call this complex factoring because there's a coefficient in front of the x squared. Step 1, multiply front and back. That gives me negative 36. What factors in negative 36 add up to negative 5? Right? So we're going to rewrite the 3x squared. We're going to minus 9x. We're going to add 4x. We're going to minus 12. And again, these are really those, just they look different. Common factor the front. And if you were in Krentz's intro class, she's really good at doing all these steps all the time, whether it's complex or not complex. Yeah, Fumi?
Do we have to show this?
No, if you can do it without showing it, because really what I'm looking for is the next part of the process. Like, this is a grade 10 outcome. But if you screw it up, then it's going to be harder because your answers won't be correct. And then out of those two, I'm going to take out a positive 4, and I'm left with x minus 3. I know I've done it correctly if those two are the same. So I'm going to have x minus 3. And if I remove that from both of those, I'm left with 3x plus 4. Now, I will tell you that if I were doing this on a test or a quiz, I would grab a piece of scrap paper and make sure I can do this. Like, I wouldn't do it on my test, I'd do it on a piece of scrap paper. Like, anytime you want to work out the factoring, do it on a piece of scrap paper. Then we have divide by, well, 12 can't be factored, and 3x plus 4 can't be factored. And then we got times, and then it's going to be 2x minus 3, and then x plus 4. I'm going to drop brackets around that x plus 4. I do that in these situations where there's only one set, there's nothing I can do to them. I put them together to remind myself that they're a set and they can't be broken apart. So that's why I do that there. So now that I have all that done, what am I going to do? I'm going to do my non-permissible values. So I'm going to have x cannot equal, and I'm going to go through them. This one's going to be positive 3. Can you do this one in your head? Negative 4/3, beautiful. Good mathin'. This one, same thing, right? If they're the same, they're going to be the same non-permissible value, and this one's going to be negative 4. All right. So if I gave you guys the question, 12 divided by 3 times 5, how would you do that? So you guys you would do this first, get the 4, and then times by 5, right? So the strategies you use with just plain old numbers is the exact same strategies you do with the more complicated stuff. The math process never changes. So we're going to look at these two first. Okay? We still need this one. It still needs to be written down, but we're going to deal with these two first. So 3x plus 4 over x minus 3, 3x plus 4. This flips and becomes 3x plus 4 over 12. I don't know where my pink marker went. I got pieces of paper everywhere. Denominator. And I still have to write down this one here. Because if you forget it on this line, the lines are no longer equivalent. Okay. Non-permissible value for this one? There is none, because what is it missing? It's missing a variable. It's missing an x, right? So 12 is 12 is 12. The only thing we're saying is what the variable can't be. There's no variable, so in this case, there's no new non-permissible value. All right, everything's multiplied, so that's nice. Do you guys want to simplify these two first? Would that make more sense? To simplify those two? Okay, so what can I cancel out? Right? Anything else? 3 over 12, right? I can reduce that. 3 over 12 reduces to 1 over 4. So I've got x plus 4 on top, and I've got x minus 3 times 4 times by 2 times x minus 3, x plus 4. All right. What can I cancel out here? X plus minus 3? X plus 4? What am I left with? 2 over 4. Would I leave it like that? No, what would I leave it as? 1/2, because that's this. And I have to state my non-permissible values. And you guys, Scallon, this is silly because there's no x. But there was an x. So we have to say that if there was an x, if you were to do it from the original, these are the values that x cannot be. So this one actually worked out to be like an actual number, not an expression. So that's kind of cool. So that can happen sometimes. I think one of your very first problem sets, maybe problem set 1, had one of those equations where things canceled each other out and your answer was negative 11. This is just one of those scenarios. So that's it. That's all.